Alright, so it's not quite done, but we certainly will get the idea. So the building collapses. I mean, none of these pieces are held to each other. I mean, it's literally a collapse. If this is all you wanted to do, as I've seen in some Rigids tutorials, it is literally showing a building collapsing. The thing is, we really need to get our glue constraints going so that we have some structure. There's some form to this, and it's not just a sandcastle dissolving. So close that. First things first, even before we do the constraints, we need to motivate the collapse in some manner. And by motivate, I mean we need to have an explosion. So come all the way back out here, and I'm going to make another geometry node. I'm going to call it force. I'll put it next to the sim, and I'll make it a light purple. That's kind of like it's simulation related, but it's not the sim. So go to show all objects. I'm actually just going to have it, I just want to have the building be here, but not the simulated version. So I'm just going to keep the construct one on for now. So here it is. In our lesson here, just as in the original Rigids 2, I want to continue to use metaballs. There's lots of ways to impart a force onto these pieces, but I think metaballs are really one of the most straightforward ways. What is a metaball? If you look at it, it looks like this weird thing. Well, right now it's just a sphere with a whole bunch of lines on it. But really what it is a field. It's more of a nebulous field. It's like a velocity field almost, if you're familiar with those. But all that is to say, we can change the radius in different dimensions. What's really cool about metaballs is because they are fields, they just do a lot of stuff that we want with an explosion for free. Meaning they're strongest in the center and their power dissipates over time. In fact, this edge that you see here is not a real edge like a polygon or anything. As you can see, it's still a metaball. What this is saying is that the weight value has reached 1, and it will actually continue out to 0 to maybe here. Weight is 2, it says here. So that 2 is at the very center, meaning it has a force value of 2 here. Then it drops off in some manner. I mean, they're all fairly similar, but basically it's some kind of dropping off of power from 2 to 1, where we see the surface, and then to 0 beyond. But what's cool is we can sum these together. So if I have this selected, you can see we can make cool shapes like this. So we have the 2 of these fields now, and they are adding on top of each other. So like I said, it's 1 at the surface here, but still continuing to 0 somewhere out here. So as the fields start to overlap, you can see they kind of melt into each other, because now the fields have summed to 1 out here. So you can build up blobby shapes with these. You can make interesting shaped explosions. The idea still being that the force is going to be exerted from the highest place in the center towards the lower numbers. So it's going to point outward from here. So in our case, I just want to place this. I basically want to seed an explosion. I want to make a disk. So I'm going to say make it half as high as it is wide. I want to see like an explosion towards the bottom, blow stuff out, weakening the building, and then having it collapse. So I'm just going to move it kind of inside of this. So something like that. And we'll move this one over. I don't really know. This is up to you, of course, where you want to put it. But I'm going to put it right around here, I think. Maybe, I don't know, it's a little too high maybe. Let me just try rounding these off maybe. So that's not bad. Basically it's, the center of it is embedded inside of it a little bit. That way it's going to push out. And obviously the center is really embedded here, so it's going to push this way. This is just a general approximation of our round field. Now our explosion won't just be a ball, even though this is a ball, because the different pieces will have different weights. And that's what gives rise to the chaotic look of an explosion, is the density, or again, just the general mass. If we know force is mass times acceleration, the differing masses means the same force will yield different accelerations because the masses are different. So now, in order to turn this into a force, it needs a force attribute. Easiest way to do that is to put a force SOP down. Turn on radial force. A force of 1 means it will actually suck inwards, as you can see from these arrows on the icon here. So flip that to -1 to have it blow out. All this did was make an F radial force attribute. We could have just done that in a Wrangler, but it's nice to use the one with the nice icon, because why not? And that's pretty much it. This force is going to be applied on every frame if we leave it like this. We don't want that, certainly. We want the explosion to explode. So let's use a switch to say switch between 2 different geometry streams. I'm going to put a null. Actually, let me delete this input and say the null first and then that. So when we're pointing to that, or let's actually look at it. When we're pointing to the first input, it's getting the meta ball. We're pointing to the 0th input, there's nothing there. So only have it point to that on the frame we want the explosion to occur. So I'm going to say when the frame is equal to 3. So on the 3rd frame. So there it is, frame 3, it exists, doesn't exist any other time. And that's it for our little setup here. You know, in our old lesson, and I'll just quickly talk about this, I had done this substantially differently, where I basically took, here I'm going to bring in the layout, I took the building, I turned it into geometry in some manner. In this case, I'm just going to use a box because it's easier. I think I used a volume last time. This box is going to sit on top of the, in fact, I'll just use a bound instead. I guess it's the same thing. This box represents roughly our building. If I make the box smaller so that it's kind of inside, like so, I could then put a scatter and say only scatter 1 point onto the surface, and the seed will change where that random location is. So we could do something like whenever $F is %3, whenever that is equal to 0, meaning 0 on frame 3, we get a point. On 6, we get a point. That's what this modulo thing does. It says don't divide the number by 3 and give me the result. It's give me the remainder. So 3 divided by 3 has no remainder. 6 divided by 3 is 2, has no remainder, and so on. So that's what this is doing. So it's saying essentially every 3 frames, put this point somewhere else. Even better way would be to, let's take this expression, delete it, put a $F here so every frame is in a different location, and now we can use that switch idea again. So now the switch can say switch to that input every 3 frames. So now we don't have a point on the other frames. So why am I saying all this? Because what we did last time was we had multiple explosions, where I took the meta ball, put it on that. So every 3 frames we had different explosions randomly assigned all over the building. There's nothing wrong with that even now. If I were to show the building, you can see it's just putting explosions all over the place every 3 frames. You could even do stuff like do it every 3 frames and when F is less than, let's say, 20. So only do it for the first 20 frames and then stop doing it. The thing with that is it was just so random that, I mean, any given shot you have, you're probably not going to have random explosions. You're probably art directing the explosions. So I thought it was cool to still mention how to do that, just for fun, and how getting random locations on a surface might look in general. But we're not going to do it. I realized later, I think, that being just art directing a key place, I want to have the explosion in the front where I can see it. I want it to be towards the side to make sure the walls blow out. You know, it's art direction, so it's just better this way. So finally, copy this, come into our sim. Oh, looks like we're on frame 3 still. And turn that off. Let's put down a pop meta ball force. So put it into our post solve input here. And I just simply have to point to it here. Now, what's the force scale going to be? I don't really know yet. We have to just run it and see. Perhaps that's enough. Let's see.